afternoon, everyone. Welcome to our next ThinkStep webinar in our series. This one is all about tackling upfront embodied carbon, and we're joined by speakers from NABERS and the New Zealand Green Building Council today, as well as Nicole from ThinkStep. So our first speakers today are Sam Archer and Katie Eyles from New Zealand Green Building Council and NABERS respectively. I'll pass you on to Sam now, who's going to talk a little bit more about the New Zealand Green Building Council side of things when it comes to embodied carbon. And then later on in the presentation, we'll hand over to Nicole Sullivan, who's our Impact Director at thinkstep-anz. So without further ado, Sam, take the stage.
Fantastic. A warm kia ora from New Zealand. Yeah, so I've got a very swift 7 minutes to cover three sort of basic areas for this presentation. First one is our embodied carbon methodology. So the methodology the Green Building Council is using in New Zealand to define how to do building embodied carbon assessments, LCA assessments of buildings in New Zealand. An embodied carbon calculator that we built with ThinkStep, well, ThinkStep built for us. And then finally, just a little bit about our current requirements around embodied carbon and upfront carbon in rating tools here in New Zealand. Okay, so I guess the journey that we've been on with embodied carbon here is that embodied carbon assessments and upfront carbon assessments have been taking place in New Zealand probably, in earnest for the last 5, 6, 7 years. When we first started looking at it, we were finding, and I think GBCA were finding as well, lots and lots of inconsistencies about the results they were getting. And I think partly the issue is that EN 15978, which is the standard that's often used to build or to do embodied carbon assessments and LCA more generally, is more of a framework, and what it doesn't give you is very specific details around assumptions to be made for your assessments. So here's just an example. If you ask 10 different consultants how long some timber cladding will last on the side of a building, that's an important input to an embodied carbon assessment. You'll probably get 10 completely different answers. And indeed, sometimes when I give this presentation, I ask people to put their hand up and give those numbers, and we do get very different numbers. And there's lots and lots of those assumptions, and those assumptions, essentially end up with very different answers. Here's another example. So environmental product declarations that are often used as inputs to an embodied carbon assessment will give you scenarios. So they'll tell you different quantities of emissions for whether you landfill, energy recover, recycle, or, your product at end of life. And as an LCA practitioner, you're meant to make an assumption and document it. But the problem is different LCA practitioners make different assumptions. And so really what's incumbent on us as a standard setting organization is to really try and lock down some of these things. Biogenic carbon is another one. How do you treat biogenic carbon, and how do you, what assumptions do you make about the ways in which biogenic carbon is removed from the atmosphere and then put back in, so from timber and things like that. So as a result of that, we again work with ThinkStep and developed a very detailed New Zealand Green Building Council embodied carbon methodology. And we launched this about a year and a half ago. And, we've got our regulator, MB, so the Ministry of Business, Innovation and Employment's endorsement of it. They also developed a whole of life embodied carbon assessment technical methodology, but we built on that and added a lot more detail, specifically around this kind of data question. So the assumptions that are built into a model around things like replacement rates. So I mentioned that timber cladding before. Here in our embodied carbon methodology, we've got, solid timber cladding. If it's used in an enclosure, you should assume that it has a 60-year life, and that standardizes things for assessments and means you've got comparable assessments between projects. Similarly, we've published, and I'm sure NABERS will come and talk about this because they've done a similar thing in Australia, tables of standardized conservative and baseline material data. So if you're doing an embodied carbon assessment, quite often you'll use environmental product declarations or EPDs for specific materials you're using. But more often than not, you won't have an EPD for the particular supplier that you're using. So we need standard numbers. So, if your particular concrete doesn't have an EPD, and it's a particular MPA rating, then we give a conservative figure to use. And then we also give a baseline figure, and that's so that you can, and this is from the year 2022, so we can say here are the improvements that the industry is making from the baseline. So, a typical average 40 MPA, 45 MPA concrete in 2022 would have been 379 kilograms of carbon per meter cubed then. And then, we can show those improvements over time. Okay, and so having then locked down all of those assumptions around things like replacement rates and default emission factors for materials, we then had this very comprehensive and very complicated embodied carbon calculator built for Green Star in New Zealand. It's essentially, it's just a spreadsheet, but it's a pretty complicated spreadsheet. Well, I say complicated, it's complicated in the background, but actually as a user, it's fairly easy to use, and that enables you to do an embodied carbon assessment using all of those default assumptions and really, really bolting down some of those things that are often variable between assessments. Okay, and then finally, where are we at with some of the targets that we're setting in Green Star in New Zealand? We've done some comprehensive work with Becca here around looking at science-based targets. So in other words, if we're to hit 1.5 degrees of global warming in line with Paris, then what does the building industry in New Zealand need to be doing in terms of upfront carbon reductions? And here you can see from May next year, at a 6-star level, we've set these targets to be in line with those science-based targets. So for an office building, we're requiring a 45% reduction in embodied carbon relative to that 2022 baseline. Other buildings, we're requiring a 38% reduction. And then we're going to have another toughening of these requirements in 2028 and then 2030. So there's this idea that slowly over time, upfront and embodied carbon reductions are going to be increasingly more stringent. 50%. I think we're heading towards, from memory, a 53% reduction by 2028, which is a very tough reduction compared with that 2022 baseline. Okay, finally, we also, for those of you in Australia who don't know, we also run a sustainability rating for homes called HomeStar. That also requires, at the moment, just an assessment of upfront and embodied carbon. It doesn't require it doesn't stipulate the actual reduction you're required to achieve. The main difference being that we do have fixed benchmarks in HomeStar. So for homes, we've worked out roughly what we think are typical emissions per square meter for upfront emissions for a home, for a standalone home, and then benchmark those. And really what we're saying is that we want to get down from, typically we think in New Zealand, a house will be around 180 kilograms per square meter, standard timber frame house. We would really like the industry to get down to 60, and so that's the target that we've set. Thank you very much. That's my final slide. I'll hand on to Katie from NABERS, who can take over from me.
Great, thanks for that. Yeah, so probably going to notice quite a few similarities to New Zealand here. So yeah, NABERS, we started developing our upfront embodied carbon tool a few years ago in 2021. We've also worked with ThinkStep over this time. So we started developing our tool by spending a couple of years talking with industry, really, everyone involved in the process of developing a building, from developers and quantity surveyors through to product manufacturers, to figure out, okay, if we're going to have an embodied carbon rating tool in Australia, what should that do? And we covered everything from big questions like, should we start with measuring upfront carbon, or should we start by looking at whole of life, through to the specific details of things like how do we measure or how do we report on stored biogenic carbon. So yeah, really ran through everything with industry to come to agreement all together, and in agreement with GBCA, and looking at international standards and agreeing with international standards as well. What are we actually doing in our tool? So went through that process, and now we have actually released the tool. So the embodied carbon tool basically consists of these 5 things. So first of all, a set of rules which standardize the scope of what you're measuring. So what materials in the building do you need to include? What emission factors are you using? What evidence can you use to prove that what you're reporting is correct? All of that is outlined in the rules. Secondly, similar to New Zealand, an emission factors database, because yes, not every product that you're using will have a EPD. So we need some defaults to use if you're using a product that doesn't have one. And thirdly, we have training. So if you're doing a NABERS embodied carbon rating, you need to be a trained assessor, and our assessors pass an exam and all that sort of stuff to make sure that everyone's following the rules consistently, so ratings can be trusted. Then certification. So the assessor sends the rating to NABERS, we audit it and check the evidence, and then we certify it to make sure that the rating is accurate and the rules have been followed and all that sort of stuff. And then finally, the benchmarking algorithm. So we have a star rating of our system, similar to Green Star, but the way that we do our stars is we have an algorithm that predicts what your upfront carbon should be based on the characteristics of your building. So what's the building type? What's it used for? Some other things that we correct for, like parking. And we compare your actual upfront emissions with what we would expect for a building of your type. And if you do better or have, less CO2 equivalent per metre squared than what we would expect, then you get a higher rating above 3 stars. And if you have more CO2 equivalent per metre squared, then you would get a lower rating. And we base that algorithm on data. In the case of embodied carbon, it was data for about 150 buildings. So yeah, the things that we take into account in that comparison, or the algorithm that we use to determine your star rating for embodied carbon, is area, what the building type is. Industrial buildings typically have fewer emissions. The height of the building, because of course the taller you get, you need, to bear more weight, have more materials in the building in terms of like bearing all of that load, and parking area, because parking that's part of the gross floor area typically is less emissions intensive than the rest of the building. So we don't want buildings to wind up with a better rating just because they have a bigger area of parking. So the building types that can be rated by NABERS in Australia, just about anything you would want to build, really. Data centres are not included there. We're hoping to be able to make that possible sometime soon. But yeah, the range of building types that can be rated is quite broad, as you see there. So implementation challenges. One of the main things, which is actually similar to what you all answered at the beginning with those questions, collecting the evidence. So because NABERS is a as-built rating of what actually happened, we need evidence of what products were used in the building and what the quantities are. This is really important, especially when you're looking at specific products and maybe you planned to have a certain type of steel or aluminium or concrete, and whether or not that was actually what was delivered to site can be questionable. And if you look at the difference in emissions between, the best products on market in terms of emissions versus the worst, it can be up to 6 or 10 times different depending on the material. So it's really important that we actually have evidence of what was built. So at the moment, what that looks like is things like invoices and delivery dockets and purchase orders and returnable schedules. But of course, if you haven't collected this during the construction process, it's really hard to go back and get it later. So we're doing some consultation with industry at the moment to see what else we can add to that list, what else might be good enough evidence. So the couple of things at the bottom there in italics, like the BIM level of design 400 or shop drawings for fabrication, we'll probably add those to the rules in the next couple of months. But other things like a letter from a supplier, that sort of thing probably won't be added to the rules, because we know from our experience with doing pilots that it can be very different from the totals when we look at actual invoices. So yeah, that's probably the main implementation challenge that everyone is having at the moment. And then worth mentioning these couple of things as well. So yeah, of course, the sooner you start estimating, the better, because it's a bit hard to do anything about it later in the design or development process. And then just being aware that total emissions might be different to your expectation. So during the pilot process, we piloted with about 30 buildings. The main sorts of things that we would see is different techniques might have been used in the past for calculating upfront embodied carbon, because in the past we didn't really have this method that everyone could look at and use the same scope and the same emission factors and stuff like that. So for example, there could be a building which used a fair bit of timber, and the stored biogenic carbon in that timber wasn't counted in the upfront emissions, which, according to international standards and what we do now, is that biogenic carbon would be counted. So, people might get a result that they're not expecting in that sense. Or another example might be a building focusing more on other design or sustainability issues. So maybe a simple example is a building having a green roof, which actually, is a good measure to take for certain reasons, but also it probably will increase your upfront carbon, because then you've got more weight on top of the building and there's more materials involved. So yeah, I think that's the really important thing about estimating early, just understanding how to weigh all these things up against each other, see how it affects the upfront carbon, and be realistic. So yeah, just to finish off, in terms of current policy in Australia, in New South Wales, we have the Sustainable Buildings SEP, and in that policy, every building, non-residential, has, over these dollar amounts, has to report their upfront embodied carbon at DA and construction certificate phase. the federal government has in their environmentally sustainable procurement policy for federal buildings embodied carbon requirement, and 4-star NABERS is one of the options to meet that. And in the next update to our National Construction Code, NABERS Embodied Carbon is also a voluntary pathway in that. Just a really quick note on GBCA alignment, Buildings V1.1 has just been released, and you'll see that the methodology matches the NABERS method in terms of what materials to count and what emission factors to use. So yeah, we're also aligned with the GBCA now as well. Nicole, I'll hand over to you.
Thank you so much to both Sam and Katie. It's been really exciting to see. They appear to be quite separate, but actually they've been working quite closely with each other, and the New Zealand Green Building Council's work was actually feeder work that helped establish the NABERS Embodied Carbon Calculator as well. So we're very grateful for the collaboration across the Tasman. I'm going to very quickly talk about demonstrating genuine reductions, because this is one of the challenges that we're really seeing projects having, as Katie mentioned. So the challenge that we're seeing is that projects are finding difficulty in getting together their evidence for upfront carbon emission reductions. And so as a consequence, it's then difficult to prove that your intended emissions reductions are genuinely achieved and then to be recognised for them. So the question is, what have we got to do? How do we demonstrate these genuine emissions reductions that we are achieving? So as Katie briefly mentioned, there are 3 things you need to prove. So for every key material as defined in the NABERS rules and your specified lower carbon products, you need to be able to prove what specific product you used, how much of it you used, and its emissions factor if that's available. For key materials, you don't have to have emission factors, but if you're choosing a lower carbon product, you do. So for those products, we need to provide evidence. So the evidence must confirm the quantity of the product and the material and manufacturer. And so Katie mentioned there's a series of different evidence requirements in the rules, and thankfully NABERS are looking at how to extend that, which is great news for industry. In addition, we have to provide evidence for our emission factors, so how much carbon is in that product. Those acceptable sources of evidence are a third-party verified process-based life cycle assessment. So that could be an environmental product declaration, a complying carbon footprint declaration. Not all carbon footprints are complying, so beware the small print there, or a climate active product certification and the product disclosure statement that goes along with that. We can also use industry average emission factor data as the worst case scenario. If we don't have that information, then it defaults back to NABERS conservative data for emissions. So how do we get the information that we need? So the recommendation is start early. We have to start really early in our projects and identify all of the potential sources of key materials and your specified lower carbon products. If you think you might need that data, start right at the beginning with identifying everything that you need that data for. Then work with your suppliers and contractors right from the start. Know what data you need to collect from them because you've already just identified it, and embed that data collection in your contracts. And specifically, my recommendation is get monthly reporting from your contractors. Because if you get monthly reporting from the start, that data will just keep trickling in and it's not going to be lost. If you ask for it 2 years after it's done, you can pretty much forget it, particularly if it's not in the contract. When you get the data, check it, validate it, make sure it's right and what you understand it, and store it securely. Have it ready for when your assessment needs to happen at the end of the project. And finally, make sure you have what you need from the beginning of construction onwards. Don't break ground unless you have that data collection process in place. Now, of course, it's not going to hold you up on breaking ground, but make sure that from that time onwards, you have a mechanism to collect that data. And you can see all the different types of data that you might need in those icons on the right. And with that, I'll hand back to Emily for our Q&A.
Awesome. Thank you, Nicole, and for all of our speakers for running through all your wisdom with us. We're now on the Q&A segment of this webinar. All right, we've got a few for Katie I've noticed that have started coming through. So I might start with those ones. So our first question, Katie, is about the tables of NABERS upfront carbon benchmarks. They're kilograms CO2e per metre squared values for NABERS 3-star, 5-star, and 6-star for the different building typologies. This person's wondering if they've actually been published yet because they could not find it last time they looked. So I'm not sure if you've got any insights into that.
Yeah, so we can't actually publish what those values would be because it depends on your building, what your parking area is, the height of the building, what your building type is. So I guess, for example, in the 150-ish buildings that we used for that benchmarking purpose to create the star rating scale, 3 stars for an office building could be anywhere between about 500 kilograms CO2e up to, I think, around 700 or 800. So, a taller building, the allowance would be greater. A building with lots of parking, the allowance would be lots of parking as in a higher proportion of the GFA, the allowance would be lower. So you can, if you use the calculator, you can put in the quantities, the material quantities for your building and figure out where you sit. Yeah, but we'll publish a simpler way, what we call a reverse calculator, a simpler way of estimating that just by entering your building details soon. I would say before the end of this year. Just haven't quite gotten there yet.
Cool. Exciting developments. That's great. I have another question for you, Katie, so might as well stay off mute. So the process you describe requires designers to estimate, then prove via documents held by the contractors. I think it's just a clarification question.
Yeah, so I guess throughout the design process, you'd be estimating and seeing where you seem to be heading, but the rating actually takes place once the build is complete, within a couple of years of the build being complete. And at that point, someone from the project team would give an assessor all of that evidence of what was actually included in the building. So we're just using the as-built documentation to do the rating. Does that make sense?
Yeah, perfect. Thank you. All right, this one is for Nicole. So how do you stop designers artificially choosing high carbon products that are then easily improved by a lower carbon product they intended to use anyway? It's an interesting one, actually.
Yeah, so there are 2 different scenarios that we operate within here. When you're talking about NABERS Embodied Carbon, NABERS Embodied Carbon actually doesn't care about a reference building. There is no reference building. So that benchmarking scale that they use, it's just all about what you achieve, not what you might have done if you used really bad products. So I think that's one of the great benefits of the NABERS approach, is you don't have to create a fictitious building that you're comparing to. If you're looking at Green Star though, so the GBCA, certainly the Green Building Council of Australia, recognised that and have established an upfront carbon calculation guide, which we help them with. And that actually specifies what the reference building specs have to be. Sam, can I throw to you to talk about what you do in New Zealand with that, please?
Yeah, sure. So it's very similar. I mean, so I've actually presented that table as part of my slides, is that we have our database, similar to the NABERS database, has a default number to use for your reference building. So in other words, you can't game it by saying, I'm going to use a shitty material, excuse my language. We say for concrete, here is an emission factor you must use for that concrete for the reference building. So yeah, you can't game it in that way.
Awesome. Thank you, Nicole and Sam.
I'll just quickly say,
Yes.
I think we all support moving towards the NABERS approach, which is fixed benchmarks, so kilograms of carbon per metre squared. Ultimately, we'd like to fall in line with that. We just don't have the benchmark data yet in New Zealand to do that.
Great, awesome. Thank you for clarifying. This one, I can probably just throw to the room, perhaps, or if anyone is particularly interested, they can jump in. So Susan says, I work with local government and much of their work is infrastructure, footpaths, etc. Are these tools adaptable for infrastructure projects? So I'm not sure if anyone wants to.
Katie?
Yeah, I can maybe. So in Australia, infrastructure have their own guidelines for measuring embodied carbon, which also references NABERS. We worked closely together to make sure. Infrastructure New South Wales published guidance and Infrastructure Australia refers to it. But for the buildings of infrastructure, yes, definitely. Anyway, Nicole?
Yeah, so exactly. So there's a lot of work happening in infrastructure in Australia at the moment. And Infrastructure New South Wales is really taking the lead on behalf of all of the states. They've got really good agreement around that. So there is a lot of work happening right now, including a workshop I've been invited to tomorrow on updates to their guidance. So please feel free to get in contact if you'd like additional information about that.
Sweet. All right. We've got another 3 questions. Maybe we'll get through these and then we'll call it there. And if you've got any more questions, send them through and we can answer them offline. So this question here could probably either be for Katie or Sam. I appreciate the intensity-based measurement works well when comparing like for like. However, it doesn't allow for reduced carbon in the form of efficient design and making buildings smaller for the same use. Are there any plans to have a methodology to allow for this?
We did look at that a bit for NABERS. I think the difficulty is for many building types, how can you say what the use will actually be? So if you're planning a residential tower, for example, you can't plan based on how many people will actually live in it because it's an unknown number. So yeah, we put it aside in that sense. Sam, do you have any comments?
Yeah, I mean, it's the same for operational emissions, right? I mean, we're constantly, people mention that at sort of webinars and things I go to and presentations where they say, we should be benchmarking things in terms of, energy per occupant or energy per bedroom, for example, for apartments. But the reality is, as Katie says, it becomes really difficult because it becomes very, very hard to work out what would have been done, if you didn't build that building. So ultimately, the industry has always moved towards emissions intensity, whether it's operational or embodied per square meter. Yeah, I think it's just very difficult to do it in the way that the question implies.
Great. No, thank you. I think that covers that one. All right, this next one here is asking for recommendations on tools that can be used on very small projects, such as a fit out, where a formal rating tool is not sought or eligible and where budget and program is limited and an ESD consultant is not engaged. For example, accessing upfront carbon data from a website, such as Rebuilt, and recording in a simple spreadsheet or template.
So yeah, that can definitely be done. I think probably one of the most exciting developments for fit outs at the moment is the GBCA preparing to release Green Star fit outs, and they are planning to have an upfront embodied carbon calculation in there for fit outs, but it will have a very simple upfront carbon calculator associated with that tool. So you will be able to bring in data where you have specific products, but they're actually looking at making available a really simple calculator that's really straightforward so that you can do a calculation. It's not going to be perfect, but it's going to really help to advance upfront carbon calculation in fit outs.
Perfect. Thanks, Nicole. And then our last question here is, maybe this is a bit of a broader one as well, but quantification often comes retrospective to design. So how do you make sure you're making good decisions or facing major redesign?
Yeah, I can jump in quickly on that one. Absolutely. Like the most accurate quantification is already after everything's been built. The time where you can have most impact is right up the front when you don't know much about it at all. And so there are methodologies that we can employ, like we run an applied LCA training course where we actually start talking about those sort of things, because there are calculations you can do up front focused on hotspots, focused on where you think the most impact will be. And you can use that and some rules of thumb to help tailor down your impacts before you have the full BOQ.
Yeah, perfect. I mean, I think that summarises that, but as that's our last question, Katie, Sam, not sure if either of you had any other thoughts?
Well, I mean, we often get asked if we can provide those kind of very simple upfront calculators for doing that. But I think the message just has to be, you should be doing some early upfront, as Nicole says, some calculations as early as possible. And I suppose a slight answer to the previous question, our embodied carbon calculator is free and downloadable from our website. I'm sure, I don't know if it's the same for the NABERS calculator, but most of those tools are actually not that hard to use. So start using them early on your projects and start getting the benchmarking done.
Perfect. Awesome. No, thank you, all three of you, very much for answering all of those questions. And thanks to our audience for sending a few brain teasers through. It's been really good to be able to clarify a few of those points. That brings us to the end of our webinar. So yeah, once again, thank you to all our incredible speakers and for everyone for dialing in today. And yeah, have a great rest of your week.
Thanks, everyone.
We have many more webinar replays on a whole host of sustainability topics. You can check them out on our website and our YouTube channel.